phi by dt. So this was Gauss law for electric field. This was Faraday's law, right? And this was Gauss law for magnetic field, and this was our Ampere's sector law with the Maxwell's correction. Yes. Oh, how did ID become that? Okay, right. So this we did in the class. Okay, so let me Ampere's sector law with Maxwell's correction. Okay, so one moment, one moment. Right, so we have how did ID become that? So why ID is epsilon naught d phi e by dt. Right, this is what you were asking, Maria. Okay, so we have changing current, right? So this will charge this plate, right? So this is a charge capacitive plate, and inside the plate there is no flow of charges, right? But we have an electric field, and electric field is how much? So electric field is sigma by epsilon naught inside the plate. This part is clear, right, Mariam? Is this? Do you remember this one? Yes, Mariam. Do you remember this part?
Yes, sir.
Yeah. So we have this electric field which is sigma by epsilon, right? And we also know that this sigma is q by a, right?
Yes,
And
sir.
and then what we do is that we take this a in this side. So this is EA, and let me write it also epsilon naught and q. So then what I do is that I take the differentiation with respect. So before that, what is EA? Yes, what is EA? Electric field into the area. So electric field lines going through the area, passing normally through the area. What is that?
Flux.
Flux, right? So this is electric flux and this is Q. Now I differentiate these terms with respect to time. So differentiating with respect to time, right? So this would be d by dt of epsilon naught d phi e by dt, and then this is dq by dt. And what is dq by dt? That is current. So that current we are calling it displacement current, because there are no charges which are flowing in between the plates, right? There are no charges going from here to here. So there are no flow of charges, right? But the charges are changed due to the change in electric flux. So that will create some current, and that we call as so that is how you get this displacement current as right. So this is how you get ID equal to this. Clear? Is this part clear? Yes, Mariam, is this clear?
Yes, sir.
So now, this part we understood that we have these four Maxwell's equation, right? And when you go to the higher class, So you will see that when you combine all these four equations, then you get a wave-like equation. So that shows that whenever there is a charge which is accelerating, so that will produce some magnetic field, and that magnetic field is fluctuating. Then it will also produce, due to change in magnetic field, there would be some electric field. So they will go hand in hand. Electric field will produce magnetic field, magnetic will produce electric. So then this will form a wave-like structure, and there would be a wave propagation, and electric and magnetic field will move like electromagnetic field. So whenever you solve these four equations, you get a wave equation which shows that electric and magnetic field are propagating like a wave. So that is what you called an electromagnetic. So let's say this is Z axis, this is the propagation, and you have this X axis and you have this Y axis. So let's say right, so you have this, so this is your EX, right? And this peak is called, so this peak is E naught. And you know that this is a sinusoidal wave. So this would be E naught sine kz minus omega t. So this Z dependency shows that this wave will propagate in Z direction. So direction of propagation is Z direction. And then you have these ones, right? So then you have these propagation in the YZ axis. So this is your Vy, and this peak is called V naught, and then you get V1 naught sine and kz minus omega t. So you can see that their phases are exactly the same, only their amplitudes. Amplitudes meaning the maximum value. So maximum value is different, but the phases of these electromagnetic waves are same. So this we understood, right? And we also understood that the velocity of propagation would be omega by k, right? Where omega was angular frequency, right? 2 pi by t, and k was, this was wave vector, right? And this was 2 pi by lambda. So when we put this value, right, then what do we get? So this becomes, this is 2 pi by t, right? And then this is 2 pi by lambda. This cancels, and we get C, which is, this goes in the upper part and this goes in this part. So this becomes lambda by t. And this is what you have done, right? So C is lambda by t, or we can also write 1 by t. 1 by t is frequency, right? So that is how we can write C as lambda into frequency. So lambda is the length and this is time. Length upon time is your velocity. So that is how you get this one. So in your 10th or 11th standard, you learn about this one, right? But from the electromagnetic wave, we are seeing that, yes, this is the wavelength and this is the frequency of the oscillation, right? Okay, and also there is also this important relation that your C is also E naught by V naught, right? So this tells us that in vacuum, the wave propagates from the speed of the light, right? This is an important relation, and we also know that C is 1 by, So in the speed of the propagation, so the speed of the propagation in vacuum, got Mariam got it. So speed of propagation in vacuum, this is oh yes, Mariam, you got disconnected. So speed of propagation in vacuum is 1 by mu naught and epsilon naught. So this we have learned, right? We saw this point in some earlier chapter, right, guys? And similarly, the speed of propagation in a medium, so speed of propagation in the medium, this is V, and this is equal to mu and epsilon, right? So here this mu is the uh, this is epsilon, and this is so permittivity in the medium, and this is permeability in the medium, and this is permittivity in the medium, right? And this is the permeability in the free space, and this is permittivity in the free space. When you combine these values, then you get the velocity of the light in free space, and then velocity of the propagation in the medium. So you see that the velocity in the medium of electromagnetic wave gets reduced. So these are the things that we learn, right? We have electromagnetic wave. We have electromagnetic wave, and they are propagating in a medium, right? This is sine kz minus omega t, and we have this v naught sine kz minus omega t, and they are moving with, let's say in vacuum, they are moving with this speed, right? And we can also write this k as function of 2 pi by lambda. So this would be sine, and this is 2 pi, and this is z by lambda minus this is 2 pi by t. So this is t. So we can also write this as E naught sine and 2 pi, and we can write this as z by lambda minus t by t. So in the question, they can give you in this type of equation. So these are the important things to learn in the electromagnetic wave. So we have electromagnetic wave, right? We have this electromagnetic wave, and they are moving perpendicular to each other. And the direction of propagation would be cross product of electric and magnetic. So this will give you direction of propagation. Right, so because you saw that this is Z direction, right? And this is I direction, and this is J direction. So I cross J would be what? I cross J is how much, guys?
K.
K, right? So whenever we take the cross product of the direction of electric and magnetic field, we get the direction of propagation. So this we have to remember. So this is the form of electric field, this is the form of magnetic field, and they are moving perpendicular to each other. And what is the speed of propagation? Speed of propagation you can calculate in this way, you can calculate in this way. So anyway, you can calculate the speed of propagation, right? And that is in the vacuum. and speed of propagation in medium would be this. And we know that V is, so what is this mu? Do you guys remember? Permeability in the medium, what was this? Yes, guys. So this is,
Like this.
so this is mu naught and mu r, right? Right?
Yes.
So this is relative permeability and then this is the free space. Similarly, we have this epsilon. This was what? Epsilon naught and epsilon r. Right, guys?
Yes, sir.
So when we put these values, so this is mu and this is epsilon. So then when we put these values, then this would become how much? So this would become mu naught, mu r, and this is epsilon naught, epsilon r. So I can write this as 1 by root mu naught epsilon naught and root mu naught r epsilon naught. So can you guys tell me what is this value? What is 1 by mu naught epsilon naught?
Sir?
Yeah. Did you say C?
No, sir.
Yeah.
Sir,
So
why did you separate?
yeah, I cannot hear you properly. What are you saying?
Why did you separate me not
Yeah.
calling out?
So I'm trying to get something which is important, and yeah. So I'm trying to relate this with something. That is why I separate. So I have this. Let's say I have this root A, B, C, D, right? So I can write this as root A, root B, root C, root D. Can I write this one?
Yes.
Then I write this together. So I write root AB, and then I write root C. But I know that what is 1 by root of mu naught epsilon naught. What is this, guys? Just go back to this one. What is this?
See.
Speed of light, right? So this is the speed of light, and then this is root of mu r and er, and this is velocity. So if I take this one in this side, right, this guy in this side, so root of mu r and er, and then c by v. So this is what I wanted to calculate. What is this value? What is this value? What is the ratio of speed of light and speed of light media? What is that? Yes, guys. Remember your 10th class. So, and remember this light chapter. So, what was this C by V? You guys remember? Refractive index, right? What is Joule? What is Joule? Yeah, so this is refractive index, right? And this is mu r. So we can calculate the refractive index of the medium using this equation, right? Okay, so this was a refractive index. This was the speed of propagation in medium, and this was speed of propagation in vacuum, and then how this amplitude are related. And yeah, so this part, these parts are important. You guys please note down these parts. Okay, please note down these parts, and then we'll do some question. Then it will be more clear. So please note down these parts. The question are asked in from these set of questions. So from these topics, the question asked. Either they will ask you the displacement current, or they will ask you this question. Yeah, so whenever you guys want me to scroll down, please tell. Right. So only two major things we did in this chapter. One was the Maxwell correction, Maxwell's equation, and the second was this electromagnetic field. Yes, whenever you guys have noted it down, please tell.
Sir, can you please scroll down?
And this relation is very important, right? How this amplitude of electric and magnetic field, the peak value of electric and magnetic field, how they are related in electromagnetic field. So this always remember this. Yes, noted everyone. Yes, guys.
Yes, sir.
Down.
Sir, can you please scroll down?
And today's class would be of 1 hour because this chapter would be over and there will be new people who will join in the later class, right? In the next class. So that is why I will not start this optics portion, right? So I will start this optic portion in the next class. Yeah, and sorry guys that I didn't take the previous class. So on Thursday I had to cancel that class and sorry about that. That I canceled that class. Yes, noted everyone. Yes, noted everyone. Yes, Aisha and Maria, you guys know it all.
Yes, sir.
Good. So, and now, can you guys tell me what is the uh, energy? So, what is the energy associated with this electric field? What is this electrostatic energy? You guys remember what is this? Not power. Power is yeah, electrostatic energy. So energy due to the electric field, that is half epsilon naught E square, right? And for this case, this is Rm, right? And similarly, energy due to magnetic field, this is half, and this is mu naught and B RMS square, right? So these are the energy. And the total energy would be half epsilon naught E RMS square plus half mu naught B RMS square, right? So these are the things. Now let us do some questions to understand all these things. Okay. But before that, let me also tell you guys about, because we are understanding electromagnetic wave, right? We are understanding electromagnetic wave. We are talking about electromagnetic wave. So what is the physical quantity that is associated with a wave? What is that? So if you have a wave, what is the physical quantity that you relate it with? Right? How do you represent a wave?
You know,
Yes?
you know,
Scalar. No, so you see that electric field is not a scalar quantity, right? E naught. Okay. So yeah, amplitude is there. So you represent the wave by wavelength, right? So this is the special property of the wave, right? It has a special wavelength, right? So to define a particular wave, we associate it with particular wavelength, right? Is that clear? So the difference between these two, uh, whatever, so trough or crust, right? So the difference between these two, crust or trough, right? So those are the wavelengths, and we associate all the waves with some particular wavelength, right? So when we observe these electromagnetic waves, so they have spatial or they have different kinds of wavelength. So they have wavelength from let's say picometer to let's say megameters, right? So those wavelengths, set of wavelengths make a electromagnetic spectrum. Because we have a different range of wavelengths. Some waves have a very high wavelength, so those are called radio waves. Those have very high lambda, and some wavelengths have very small wavelengths. So those are called gamma rays. Right? They have very low wavelength. So they all these electromagnetic waves form a electromagnetic spectrum. So electromagnetic spectrum is all the sets of electromagnetic waves which have different kinds of wavelengths, and they have different origins. They have different origins. They have different wavelengths, and they have different properties. They have different detections. So all these things which are given in NCRT, so you guys have to read about that, right? So please read for the electromagnetic spectrum. For the electromagnetic spectrum, go through the NCRT, right? Because you have to just remember those things. So what is the detection, or what is the origin, or what are the uses of these electromagnetic waves, right? So the light we see in our daily life, so that is also an electromagnetic wave, and that has also some particular range. So for example, we have this light, right? And this is lies in the visible range because we can see light, right? And these are called visible rays, and they are from 400 nanometers to 700 or 600 nanometers. So they have the right. So all these ranges we have to just see from here. So let me bring that book. So there are different characteristic of electromagnetic wave at a different wavelength, right? So you guys have heard about this radio, right? So radio waves are used in these radio stations, or for the case of the military also. So military people talk with themselves in different radio range, right? So whenever we want to send our signal to a very far distance, then we will use a very longer wavelength. right? So in that sense, for the communication purpose, we use this radio wavelength. And let's say we have different X-rays, we have different gamma rays, we have infrared rays, ultraviolet rays. So all these waves comes under the electromagnetic spectrum, right? Because they have different origination and they have different wavelengths and they have different uses also, right? So all these things are given here, right? So this is the wavelength, right? So this is very small wavelength minus 40, right? So picometer is minus 12 and femtometer is minus 15. So minus 14 to let's say 10 to the power 7 meters. So this is the range of the electromagnetic waves. So the smallest wavelength is gamma rays and the highest wavelength is radio waves, right? And then we have in between gamma rays and radio waves, we have this X-rays, ultraviolet, visible, which is 400 to 700, right? And then we have this infrared, microwave, short radio waves. So all these different waves have different purposes. So please go through this, make a note of these things, write the origination. So just for see for the example of radio waves. So they are originated, they are produced by accelerated motion of the charge, right? So rapidly charges are accelerating and they will create some radio waves. So please go through these, right? Yeah, so then this chapter is over. So anything that you want to ask, Aisha, from this chapter? Yes. Any question from this chapter, Aisha? Yeah. So what did we learn in this chapter? We understood about displacement current. We understood about this Maxwell's four equation. And then we also understood about this electromagnetic waves. How do they propagate? And what are the ranges of this electromagnetic wave, right? And what are the properties associated with those electromagnetic waves? So we have different kinds of electromagnetic waves from gamma rays to the radio waves. And all these different waves have different properties. So this was the chapter. Now let us do this question. So now let us do some question and then it would be easy to understand. We have this question. So let us do this question. Answer is showing, but forget about this answer. So let us do this question. So a plane electromagnetic wave of frequency 25 megahertz. So frequency is given, right? 25 megahertz. So what kind of electromagnetic wave is this? This is lying in the 10 to the power 6 range, right? So what kind of wavelength is this? Yes? Can you identify, Aisha? What kind of electromagnetic wave is this? So just see the example, right? This is highly oscillating wave. So just see it from here. So 10 to the power 6, right? So that is radio wave. Clear, Aisha? So this is frequency and this is wavelength. So smallest wavelength will give you highest frequency. So gamma rays have highest frequency and they have lowest wavelength. Similarly, radio waves have lowest frequencies, but they have highest wavelength, right? Okay, so the question was we have this frequency, and we want to calculate. So electric field is given. This is 6.3 J and volt per meter, right? And the propagation is along x direction. So propagation, what is the direction of propagation? Yes, yes, Aisha. What is the direction of propagation? X direction. So what is the x direction?
I.
I hat, right? So I hat is the direction of propagation, and electric field is given. So magnitude is given. E naught, you know, that is 6.3, right? So what would be magnetic field B naught? Because in the question we have to find what is B at this point. So we have to find out B vector. So B vector will have some magnitude, and this will have some direction. Let's say direction is n hat. So we have to find out what is B naught, we have to find out what is n hat. Right? These two things we have to find out. So to calculate B naught, what property we will use? Yeah, we know that C is B naught by B naught, right? So B naught would be E naught by C, right, Aisha?
Yes.
So then we can directly calculate. Let us write. So this is 2.1 into 10 to the power minus 3. Let me directly write this, right? So this is the magnitude, and it will also have the direction. But what is the thing that we know? That direction is E cross B. So that is the direction of propagation, right? And we know that direction of propagation is I hat, right, Aisha? And yeah, Mariam, you just joined. So we are doing this question. Okay. So the electric field is given, and we want to calculate direction of propagation is also given, and we want to calculate what is the magnetic field at this point. So first we calculated the magnitude, and then we have to calculate the direction. So we know that direction of propagation is E cross B, and this is given I hat, and E is J hat, right? And let's say this is N hat and this is I hat. So we have this I, J, and K, right? So we are calculating J cross something, which will give you I hat. So what would be N hat in this case? What gives you what J cross what gives you I hat?
Yes.
K, right? So the direction of magnetic field N hat would be K hat. So then your magnetic field would be how much? Magnetic field would be B naught, which is 2.1 into 10 to the power minus 8, and that is
So your
K.
voice is cracking.
Yes, my voice is cracking.
Yes, sir. It is fine now.
Oh, it is fine. Yeah, so did you understand, did you guys understand this question? Yes? Is this question clear, guys? Yes, Aisha and Mariam, is this question clear?
Yes.
Yeah, so this you can also do, right? Now let us do this question. So this is very important. This part they ask in the exam. So this is very important, right? So you guys do this problem on your own again, right? This is given in the example also. But you guys try that question, and yeah. So this is let us discuss about this question. What is that? Mariam, internet is not working. What is happening? So why this is not easy? If we close this one and then start again, let me start this one. So any doubt in the electromagnetic wave chapter, Aisha? Any doubt?
No, sir.
How was this chapter? Difficult or
Easy.
easy? Easy one, right? Because we have only had 2 or 3 topics to that, right? Good.
Yeah.
Mariam is joining and then what is happening? Yes, Mariam, what is happening with your internet? What is so let us someone is going to join, right? So he is not here. In the meanwhile, we can solve can you guys try these questions? These are very important, right? Yeah. So this question is very important. This one. Now it is correct. So we have this magnetic field which is in the y direction, and this is some v naught sine of, and this is kx plus omega t, right, guys? Right?
Yeah, sir.
So we are given this Vy and this is K and this is omega. This is the general form, right? And what is the direction of propagation? Can you guys tell me? Yeah. So what is the direction of propagation of this wave? X direction, right? Clear? Is this clear, guys?
Yeah.
Yeah. So the wave is propagating in X direction. Good. And yeah, absolutely. So you wrote J, Maria. No, this is O. This is I. Good, yeah, fine. Okay. Now, what is the wavelength and frequency of the wave? Right. So we have to find out frequency. Angular frequency is given, and wave vector is given. So we have to find out what is wavelength, lambda, right? That would be 2 pi by k. And we have to find out the frequency, right? So frequency is how much? Omega is 2 pi by t, and 1 by t is frequency, right? So this frequency would be how much? Omega or so this frequency would be omega by 2, right? Is this clear, everyone? Yes,
Yes,
guys.
sir.
Yeah, so what do we know? We know that V naught is 2 into 10 to the power minus 7 Tesla. We know that K is 0.5 into 10 to the power 3. We know that omega is 1.5 into 10 to the power 11. right? So these are the things which are given. So let us find out lambda. This would be 2 pi divided by 0.5 into 10 to the power 3. So how much is that? So this is 2 into 3.14 divided by 0.5 into 10 to the power 3. So I don't know. This is how much? This is 6. So that more would be 1 point something into 10 to the power. Okay. Yeah, so this would be lambda, right? And we can also calculate frequency. So that would be, okay, so I will stop at here, right? Because some other person is going to join. And you guys, please, so I will send this question as your homework. You guys, please try this question, and then in the next class, we will revise some portion, and then we'll start optics. Okay.
Okay, sir.
Yeah, and the next B part is we have to find out E. So this would be E naught and sine of kx plus omega t, because the phases are same in electromagnetic waves. So E naught we have to find out, and you guys can calculate E naught. Yeah, so okay, so Mean has joined. So I will stop here, and you guys please do this calculation at home. Okay, everyone.
Yeah, sir.
Yeah.
Yes,
So
sir.
Allah Hafiz, Aisha, and Allah Hafiz.